We are getting on the fast track now. Up till this point in the series, we have discussed what I would call the core of Amazon Web Services, EC2 and S3, kind of putting storage together with computing, which makes a pretty awesome cloud solution. But now we have to start looking at what else is in this cloud suite of products, also realizing we are in what I would call the AWS Foundation series. Now, we're going to go into far more depth on these products as we get into the AWS architecture and all the other AWS certifications that are to come. We'll, of course, explore these, but my goal right now is to do this. Those are mountains. And I'm going to take off the tip of every single one of them. Virtual Private Cloud, Elastic Load Balancer, Route53. I'm just going to tell you what they are, where they fit into this solution, and how you can start thinking about how this would work for your organization. If someone were to grab me and say, Jeremy, in the realm of IT, information technology, what area are you most comfortable in? Without batting an eye, I would say networking. That is by far my prime skill set. I've spent decades of my life teaching people, especially Cisco networking, how to implement routers and switches and design and troubleshooting and architecture. I mean, that's been a world I've lived in. So when I came to Amazon and first spun up an instance, and my natural inclination is to open a command prompt if it's Windows and type in ipconfig because I want to see what's going on there. And when the command prompt window opened, I was presented with an IP address of it was something like 10.1.5.93 with a subnet mask of 255.0.0.0. And I looked at that and I was like, you can't do that. You just don't see that in the world today. That's considered Class A networking, and this tells you just how much networking I do. I know just by looking at that gives you one network of 16,777,214 usable host addresses on that one network, and it doesn't scale because if you go beyond 500 or so hosts on one network, the traffic and broadcasts just start becoming out of control. So I looked at how Amazon does it. I was like, okay, they're doing something magical. What's not magical about Amazon Web Services, right? It's like next finish, and you have this server farm in the cloud complete with routing and I mean, it is magical. And what are they using behind the scenes? I don't know. VLANs, private VLANs. There's a lot of networking technology you can use to manage something like that. But from your perspective, when you first spin up an instance and 2 instances and 3, you don't care. You just know that all of those instances can talk together and they're all on the same network, and there's nobody else at Amazon Web Services that's able to somehow get in and invade my system as well. That's what they do. But now this setup has been coined AWS Classic. And maybe by the time you're hearing this, it won't even be coined anything at all. Whenever you hear something called classic, that usually means it's being retired, like legacy, like a vintage record. That's classic, man. What it's being replaced with is Virtual Private Cloud, VPC, which gives you the control of your own private network. Now, it does require you to know a little bit more about networking than somebody using the classic environment, but gives you all the flexibility that you need in the world. You can make your own subnet. So you have your Amazon world, and I can say, okay, I've got subnet 1 right here with my instances, and these will be maybe my web servers that are connected to the internet right here and can receive the web traffic. And that might be, maybe I don't want to use the 10 network. I want to use 172.16.1.0/24. That's our subnet mask of 255.255.255.0 on those devices. There's server 1 and server 2. And then I want to create another subnet down here, which might be my database servers. And I want to use 172.18.1.0/24 for that, and I'll put my database instances in there, and then I can set permissions and control between these different subnets inside of this. Now, normally in EC2 Classic or AWS Classic environment, you've got security groups to secure your inbound access, but security groups are limited in that they can't secure what is going out. Now, for most of the time, that's fine, because how many people want to restrict themselves, right? Well, I know some of you are like, I do, and it's like, well, it could be. There may be instances where you don't want your servers getting out on certain points because, what if somebody's running a service on them that shouldn't be? What if your machine gets infected, heaven forbid, with something and starts attacking the world? I mean, you might want to put some filters on that. Well, with VPC, you have the ability to use full-blown access control lists. Now, that's a Cisco word if I ever heard one. I've taught years of access control lists in the Cisco world, which give you total flexibility to control both inbound and outbound what is being allowed from those servers. Now, these are all integrated with elastic IP addresses, or let me rephrase that. When we get to AWS architecture, we'll see the multiple ways you can set up VPC. I would say the number one way is that it is integrated with elastic IP addresses. And if you haven't heard this term before, it just means a static public IP address. See, in AWS Classic, when you spin up an instance, that server gets a public IP address, but it's actually associated with a DNS name. Now, if you turn that server off and then turn it back on, you get a different public IP address. It's always changing, always rotating all around. But in this world, you might say, you know what? I like it a little more stable than that. I don't like my servers getting different public IP addresses because then I got to rely on DNS and different ways to make sure people know where that server is. So elastic IP addresses will allow you to bolt that static IP address down to that instance. So even if the instance shuts off, you still retain that static IP address or reboots or whatever. You don't get a new one every single time. Now, VPC also gives you the ability to set up site-to-site VPN to your AWS environment. Let me clear this off for a second. So up here, let's just say is the cloud. Let's make it fluffy. Here is our little world that we've created with VPC. We put our instances inside of there, and we create a subnet 172.30.1.0/24, right, as our subnet there. And I've got my company X down here that I want to be able to access those servers directly. Well, to do that, you can use a VPN. It's actually known as a site-to-site. I'll put S2S, site-to-site VPN. So down here, what's at this end? Whatever. Firewall. Whatever you can use to terminate a VPN is there. Now, of course, I would recommend buying a Cisco device, like a Cisco, if it's a small business, maybe an ASA 5505. Those are fun little boxes that you can stick right there, and it bolts up a permanent site-to-site VPN between your business and them. So now you can start doing direct replication. Maybe if you're doing offsite backups from your company up to these servers, maybe the firewall is right here to the internet. You're saying, oh, I only allow port 80 in. Well, if you get a site-to-site VPN, there is no firewall. You can get right beyond and get full access to all those servers for management. I mean, come on. That's amazing. That's cool. It's almost like you're connecting right in to the data center. That's the kind of flexibility that you get when you use VPC. Next up in the list is the Elastic Load Balancer service. This is a little gem of a service, allowing you to take incoming traffic to your EC2 world. So here's the internet, right? People coming in to access whatever your services are and distribute it among multiple instances. Now, it gets even better than that because an ELB is region-wide. So what I can do is create an Elastic Load Balancer, and I can say I want to add instances from 3 different availability zones in the region. So let's take an example. Did you know, I don't know if you would know this, but I actually, one of my hobbies is a fish tank. And a long time ago, I had a fish cam that I set up a streaming camera back before it was real easy to do that. I actually had a computer I set up next to my fish tank with a USB camera. Anyway, long story short, let's say I want to bring the fish cam back. So I create fishcam.com. I can't ever throw a domain up there without going, oh man, I hope nobody goes to that and there's nothing inappropriate there. So you better believe I'm going to check that right after I'm done here. So I've got the fishcam.com that takes my fish tank camera and streams it to the world. And I want to, first off, load balance it between multiple instances in multiple data centers. Well, that's what the Elastic Load Balancer does. Now, It also does, can I jump right down to here? It also does health checks. So maybe this instance is like, he's on, a lot of times you'll hear Amazon technicians refer to a noisy neighbor. Maybe you're sharing, this instance is sharing a physical server with a noisy neighbor who's using a lot of bandwidth and a lot of resources on that server. Well, before Amazon Web Services gets that under control, this guy may be choking and dying. Well, you can set parameters on ELB that says, okay, if you fall below a response time of such and such, or if all these criteria that you can set up that if that guy does not pass his health checks, he's pulled out of the load balance cluster, so he's gone until he starts meeting the health check criteria. So you drop down to 2 servers that are streaming the Fishcam for you. Now, maybe I want to set up security for my Fishcam. I can do SSL termination and processing on the Elastic Load Balancer. Now, that's great. 2 reasons. One, I don't have to worry about, if you've ever done SSL before, you know that you have to get a security certificate and you have to install it on all your instances and all that. Well, with this, you can actually offload that to the load balancer. So you just install the certificate up there, and it takes care of the SSL termination for you. So it can pretend to be the website itself to all of the people who are surfing your fishcam.com out here. And I would say even better, equal or better, would be the processing, because handling encryption takes a lot of load on your instances. So your processor would spike if you had to process SSL or encryption directly on each one of them. So you can offload all that to the Elastic Load Balancer. Very cool. I'm working my way up here. Can be used internally and externally. So maybe these are my web servers. I can actually provision an ELB between maybe the web servers and all of my database servers. So maybe I've got 3 database servers. I know this kind of breaks down because well, not really. Let's say these are read-only database servers. I can have Elastic Load Balancer here, so my load from my web servers gets distributed between the database servers, just like the load coming to the web servers distributed right there. Now, I'm thinking back when I was in where was I? California, somewhere. I was talking to some AWS engineers up there. We were in the class, and somebody asked a question. They said, "Isn't this a single point of failure?" And they go, "Well, no, because the ELB now." So, and the real reason for their question is that they want to know, what is that ELB? I mean, obviously, if you've got 3 instances but 1 ELB, if the ELB goes, then all 3 instances can't process traffic. And I would say that's a totally valid question. And the AWS engineer came back and said, actually, the Elastic Load Balancer is multiple devices. It's always redundant devices that are in there. And that's all I'm going to tell you. And so I thought, well, it still doesn't make me feel warm and fuzzy, because, as I'm looking at a highly available system, I want to make sure that my ELB is truly redundant. I mean, maybe it's 2 devices. Well, I want 4. I want 8. So not long after that class, Amazon released this announcement that said Route53 DNS can also offer ELB health checks. So one step above that, and we're actually going to go there next. So Route53, I can actually provision multiple Elastic Load Balancers to where my DNS server is doing health checks to see which one is online. And maybe I have a primary and a backup. And if the primary ever goes down, it can flip to the backup, which can then take over for that service. Now on to Route53. We live in a technological world with routers and switches and servers and storage and backup and redundancy and all that, but when it all comes down to it, people don't care. they want to go to their web browser and they want to type in google.com and get their search engine up there, right? IT is an underappreciated art. So DNS is the thing that makes all of IT friendly and is one of the biggest single points of failure in the network. I mean, we just talked about the Elastic Load Balancer, right? You could have 12 Elastic Load Balancers that are redundant, pointing to a total of 150,000 EC2 instances that you have running in the cloud. But if your website is fishcam.com, right, and somebody goes to fishcam.com and something breaks down and it doesn't resolve the IP address of your first load balancer, the whole system is for naught. It all fails. So a DNS failure can cause a complete system failure. Also, DNS latency, meaning slowness of your DNS server, can make your system look slow and clunky. I mean, you may have, again, 150,000 EC2 instances with the best thing, but if your DNS server is slow, it slows the whole thing down. And that's because web pages nowadays are complex. A web page, most of the time is not just one server running that page. I mean, let me give you an example. I go to, let's go to CBT Nuggets, right? CBTnuggets.com. And you can see right there that we've got different components. Like right here is a little video that's probably fed from a separate server. Up here's a little chat engine. Matter of fact, you can see it when I move my mouse over the chat. Look at the bottom. Hang on, hang on before I bother the salespeople. Down at the bottom, you see the bar. See that? Maybe right there. Server IAD live person. So that's a totally different server. As I hover over this, it's cbtnuggets.com hash. I don't know. It's cut off. So all these different things can come from different servers, image servers, all that kind of stuff, and be hidden behind that one thing. So when somebody goes to a website, it may have to actually resolve 50 different domain names. I mean, go to Fox News or MSN.com, and you just get these pages that are really just fed from 20, 30 different servers. And if your DNS server is slow, the whole website just kind of slows down because it takes time to resolve all those names to IP addresses. Now, most DNS providers are not distributed and have very little documentation with what their DNS server really is. Like, is it redundant? I don't know. I just signed up for a hosting account at, Bluehost.com or GoDaddy.com or Dream, whatever. There's all kinds of hosting providers. And they'll, oh yeah, we'll just throw DNS in. It's one of the things you get when you sign up for an account. Well, nobody thinks that's, well, how many DNS servers is it? And what's the guaranteed response time? You see where I'm going with this, right? Route 53. What is it? It takes advantage of the entire worldwide infrastructure of Amazon Web Services. Now, I painstakingly say that slowly because I want to emphasize I'm not just talking the regions. Remember when we started the whole series? We did AWS. Let's see, global infrastructure. There we go. How about that? AWS global infrastructure. And one thing that you see is you go, okay, well, there's all these regions, right? These big yellow dots, but there's all these edge locations as well. What are the edge locations? They're areas of the world where you can't go and host an EC2 instance because it's not available for you to use, but there are some resources that can use. They don't show here. I think if I click this, they actually show all the regions. Yeah, there we go. Look at that. All of these different go back. There we go. All these different regions right here. Dublin, Ireland, Fort Worth, Texas, Hayward, California. All of these different things are dedicated to CloudFront, which we'll talk about later, and Amazon Route 53. So when you sign up for DNS at Amazon. Matter of fact, I will tell you, that is what first got me into AWS, is distributed DNS, to where you get not only one DNS server like you get with a lot of the hosting providers, you get, a lot of them. How many? A lot. There's at least one in one of those edge locations. But you also get, if somebody in Arizona goes to my Fishcam website, they get the nearest DNS server that can respond. Well, it depends on how they configure their DNS, but we can structure this in such a way that it will use the closest DNS server to them to give them a response. So for instance, in Dublin, Ireland, they're not coming across the sea to resolve fishcam.com to an IP address. You see what I mean? So it's a huge advantage to use this, and it's so cheap. I think I'm trying to remember the price. I think it's 50 cents for your first domain, and 50 cents a month in Route 53, and then 50 cents for the first million requests, resolution, like name to IP address resolution. So it's really, I mean, it's a no-brainer on the expense size. And it has even multiple load balancing options. You can go into Amazon Web Services and say, okay, I've got multiple IP addresses for my website. I want you, it's kind of like an elastic load, like a really lightweight elastic load balancer, to where it can say, okay, well, the very first person goes to this server and the next person goes to this server. You don't, can I make sure I emphasize? Sometimes I take this for granted. You don't have to use Route 53 DNS for Amazon Web Services. Now, and that's what I was saying. That's how I got into Amazon Web Services. I came in just for their amazing DNS server. I wasn't using any other, no EC2, no nothing. I just had my website, I'll say fishcam.com, and I wanted to have that being used for name resolution because it was so reliable. Furthermore, they even open an API to it. Now, what I mentioned earlier in the series, an API allows you, from a programmatic perspective, like somebody who codes and writes programs, can interface with Route 53. Well, you might say, well, what would I use that for? Let's say you you've got an online gaming website. Let's say games.com, and and games.com, I let people sign up for an account and they pay per game that they play. Now, when they do, they actually will get their own little subdomain of games.com. You know, I'd get like Jeremy. If I was the first Jeremy to sign up, jeremy.games.com, where I would get my stats board, and you know I would be able to say, okay, well, how was I doing on all my games? So I could go to jeremy.games.com and see all my stats. Well, this process of creating that subdomain of games.com can be automated. When somebody signs up for an account, it automatically interfaces with the Route53 API and allows you to generate DNS records, and this is actually an A record, DNS A record, to resolve that name. Well, it could be an A record or it could be a C name record. I'm already debating myself. Create those DNS records for the users of your website. It also supports server health checks. So Route53 can go out there. Now, I think that's an extra cost if you wanted to do that. But for instance, maybe you've got 3 servers not in Amazon Web Services at all, 1.1.1.1, .2, and .3. Well, you can have DNS constantly sending a ping message to them or testing a certain port and making sure all of them are online. If one goes offline and stops responding, then DNS no longer gives out that IP address when somebody tries to come to your website until it comes back and responds to the health checks. All right, last 2 services, starting off with CloudWatch. These are your eyes to the cloud, which is included with your AWS subscription. When you sign up for an AWS account, you get basic CloudWatch monitoring. So what does that mean? It means you watch the different components of your EC2. I'm saying EC2, but you can actually monitor all kinds of things. The ELB, you can you can monitor just about every section of Amazon Web Services. With basic, meaning the free version, if you will, it is a 5-minute frequency. So I can check the processor time of my EC2 instance every 5 minutes. I can check the memory utilization. I can check, all that kind of thing. Only once every 5 minutes. Now, a lot can happen in 5 minutes. You might have a processor spike that goes for 3 minutes, which really causes a performance impact, and you wouldn't see it potentially if you're using the basic version of CloudWatch. So they have detailed monitoring, which reduces your time interval to a 1-minute frequency, which then gives you, a nice pretty graph of 1-minute intervals that you can see over the day, how your processor utilization is doing, and all of that. So that's nice for management, but more from a technical perspective, I'm more interested in this one. I want to be able to set alarms which can take automated actions. Like if my processor is creeping up a little high on my EC2 instance, maybe I've got 2 EC2 instances or 3 that are being load balanced with ELB, like I just was mentioning before, and this guy suddenly pegs out at 100% processor utilization for 20 minutes. I might say, okay, that's not normal, especially if the other guys are sitting around 10% processor utilization. I bet a process has froze on there. I want an alarm to go off which notifies me, maybe sends me a text message or an email, and then also pulls this guy out of the ELB bundle. So now it's only load balancing between the 2 good servers that are left. That's just one example of many that you could do. Now, you can even do your own custom monitoring through the API, meaning there is a CloudWatch API. So I can say, I want to watch something. I mean, you can, once you're in the programming world, it's like, well, what do you want to do? I want to watch and make sure that there's less than 1,000 pictures in that folder. And if I ever get more than 1,000 files, then I want to sound an alarm through CloudWatch. Well, they'll let you do that, because you can integrate whatever systems you've got on watching your own system with their API to sound alarms, which then, the beauty of CloudWatch is then it can link to all the different notifications. It's called SNS. We'll talk about that a little bit later. Simple notification service, which can send emails and text messages. They can do all kinds of things. So last piece of this is that this does integrate with auto scaling. Auto scaling is the last service I want to talk about, and I put the little heart because this is so close to the heart of what elastic computing is all about, and the whole heart of what Amazon Web Services is there for, the big advantage of this. Auto scaling allows you to grow or shrink EC2 instances on demand. Now, I know when I use words like on demand, you think, oh, is that the billing model? No, I mean on demand as in when you need it. So springboarding right off CloudWatch, you might say, you know what, I've got 5 EC2 instances that power my website, my fish cam, and I'm getting a lot of traffic because my fish are really interesting. And as soon as I start seeing the number of requests, so on demand, what is on demand? Well, it means whether you're using CloudWatch, what we just talked about, to say, once the processor gets to this level, or I get this number of requests coming in, or I reach this bandwidth utilization, then go ahead and spring up another EC2 instance to handle the load. Or you can do it on a scheduled basis. You can just be like, you know what? I know come 8 a.m. we're going to get slammed because that's when the stock exchange opened, and we run you know what I mean, right? So you can just schedule it 8 a.m., bring up those 3 EC2 instances with auto scaling, add them to the cluster, and then once we hit 3 p.m. it dies down, so we terminate those and then save on costs over the evening. Right? So auto scaling can also tie in with SNS, I was just talking about, simple notification service to notify you when auto scaling events happen. So you might say, well, this is kind of a budget issue. I don't want to just start spinning up instances if I don't know about them. So you can say, hey, send me a text message every single time a new instance is brought up or torn down. I want to get a message letting me know that I've done that. Now, whoa, hold on. I just looked at that. I was like, you could totally misperceive that. Auto scaling has no additional charges, meaning this function, right? Everybody good with that? So to use auto scaling is free because Amazon knows you're going to pay in terms of storage and bandwidth utilization and EC2 instance time and the instance size and all that kind of stuff. So to grow or shrink your infrastructure is no additional charge, but you have to be a command line ninja. To this day, which is where are we? Mid 2013. There are no GUI utilities to implement auto scaling, so it is all a command line driven device. So you can think about it. There's so much that you can do with auto scaling, and there's so many examples. I'm like, there's so many examples you can give. I can't even think of one right now. Okay, let's take this example. Take it for what it is. We'll see if it flies. You run a video website that allows people to post videos online in some way, some form. So what you do is you have the web servers, accept the video submissions from these people, store them on an S3 bucket, right? And then you have a bunch of other servers, we'll call them the transcoders, which are watching this S3 bucket, and if anything hops in there, they immediately start chewing it up and spitting it out into all the different formats, high res, low res, screen size, iPhone format, all the different formats that would exist to stream video to the different devices of our world today. Well, what you can do is you can start saying, you know what, I want to create a CloudWatch system that says, when this directory gets above a certain amount of files, and it might use a custom API to do that, you might not, or when my transcoders are all, sitting at 100% CPU for a long amount of time, meaning they're just busy, they can't keep up with the number of files that are growing inside of that directory, then I want to start bidding. You could even use spot instance. I want to start bidding and adding more cheap transcoding units to my cluster so that they can start knocking down that queue. And once the queue falls below a certain amount, then I want to go in and terminate all these extra instances to make sure that I save on cost and I'm not paying for EC2 instances that I'm not using. So again, that's just an off the top of my head example of something that you could use with that. But auto scaling, think about growing and shrinking, right? That's all it does, is grow your infrastructure on demand. Now, I will say I am taking this word very fuzzy. When I thought virtual private cloud, I'm like, oh, that's all networking. Elastic, oh yeah. But as we start getting here, it's like, it's not. I wouldn't qualify those as networking services, but they kind of are. So what we've done here is we've seen the 5, I would say, networking-ish services that are in Amazon Web Services. Virtual Private Cloud, allowing you to manage your own networking. Elastic Load Balancer, distributing between multiple EC2 instances. Route53, the most powerful DNS system in the world, seriously. Auto scaling, allowing you to grow your infrastructure based on schedule, based on metrics from CloudWatch, which is your monitoring system in there. So all these services combine together to just enhance what you're able to do. I hope this has been informative for you, and I'd like to thank you for viewing.